Hello, thank you for having me. My name is Taraqur, and I'm a co-founder and data scientist at Owl Integrations, formerly known as Project Owl. And it's such an honor to be here. This is my first time in Dubai and my first time at the Global DevSlam. So thank you for having me, and I'm looking forward to presenting in front of the amazing audience. So enough about me. So today I'll be talking about connectivity and how it's key in our daily lives, and how sometimes we may be taking it for granted. So before I start, I want to do a little exercise. When I say the word connectivity, what's the first few thoughts that comes to your mind? Well, for me, when I think connectivity, I think about someone on their phones, messaging friends and family, social media, answering work emails, and that's true. Like that's basically why the reason why we always are on our phones, because we want to feel connected. We share what's happening with our friends and family because when we do that, we feel connected to them. When we answer work emails, we feel connected to our team and then the values of our company. And then when we scroll through social media, look at the news, and figure out what's happening, we feel some sort of connection to the whole world. And today, my agenda would be to kind of like the movie Inception, kind of like incept an additional idea to when you think about connectivity. And that is having a simple, resilient network made by everyone can make a difference in critical times. So I purposely emphasize three words here: network, everyone, and critical. And throughout the presentation, we will excavate the purpose of me emphasizing those words. So first, I want to talk about critical. So with the raise of hands, how many people have experienced or know someone who have experienced a natural disaster? Yeah, it's very devastating, and this is a huge global issue. This picture is actually, it's a very recent picture. This is Hurricane Ian that passed by the Caribbeans. So examples of natural disasters are hurricanes. We have earthquakes in Nepal. We have wildfires throughout Europe, Australia, California. And these disasters affect the survival of humans. And they also affect the supply chains of food, water, and medical help of us. And not only does it destroy like infrastructure, but it also destroys like power grids, electricity, some things that we use in our daily lives. And today I want to focus on more of this connectivity, because this is where connectivity becomes super critical. Because if we don't have connectivity, then the civilians won't be able to reach out for help, tell them, oh, I need some medical attention, I need food and water, and first responders won't know where to go or how to help out the people. So if connectivity is an issue, what are the problems? So we need to restore comms or communications with civilians. That's number one. So we need some sort of network. If a hurricane comes by and destroys cell towers and any electricity, we need a way to just quickly deploy a network so that we have some sort of connectivity. Once we have that network, people can submit some information. How do we get the information? So that's number two. If we get that communication gone, how do we get that to the right people, like first responders? And number three is we need a simple but resilient solution. So if the users can share the information, and if during disaster, if all the infrastructure is down, how do the users get their information to the right people? So at Owl Integrations, we came up with a solution. And for the number one, for restoring communications, what we do is we deploy IoT devices called ducts, where users, civilians, can connect to these ducts and submit their critical status. I need food, or I fell, I need some medical issues, or the flood is rising and I have nowhere to go. So we have that information. So now the next part is, how do we relay that critical information? So once the users submit the information to the ducts will be able to transmit the data to other ducts using LoRa technology. For those who don't know, LoRa is short for long range, and it's a protocol used that has low bandwidth and low power, so that helps out a lot when there's no power. And yeah, so, and it can go far distances as well, communication between two nodes. I believe the world record right now is like 800 kilometers from one node to one node, direct communication, and this is in a controlled environment. So yes, 800 kilometers. So that sounds amazing, but the trade-off is that it's low bandwidth, meaning low data rate. So yeah, if you connect to a lower network, you won't be able to watch Netflix, but you have enough power to send that critical status so that first responders can help you out as much as possible. So the information gets relayed from duct to duct to duct, and once it hits a gateway duct, a special duct, the gateway duct can push the data into the cloud. And so, yeah, so you might wonder if there's no infrastructure, how does the duct do that? So that's number 3, making a resilient network. So the gateway duct can send the data through internet, can send it through cellular, or if those two are not available, it has the ability to push it up to the cloud, to the satellite, and bounce the data off from the satellite to the cloud. And once it gets to the cloud, end users such as first responders or any type of operators can extract the data and make actionable insights from that. So to summarize, we deploy IoT devices called ducts, where users can connect to it, submit their critical status, and it permeates the data using LoRa to a gateway duct, and the gateway pushes the data to the cloud using internet, cellular, and or satellite. And since we deployed these ducts in clusters, naturally we called it the cluster duct protocol. So in March of 2020, we actually open sourced the cluster duct protocol with the Linux Foundation. So before I talk about why we did it, I just want to define what open source is. And Red Hat, which is a great company known for open source technology, defines open source as open source software is code that's designed to be publicly accessible. Anyone can see, modify, and distribute the code as they see fit. So now, why would we open source it? There's plethora of reasons of why why companies can benefit from open sourcing technology. Unfortunately, I do not have enough time to talk about it, but what I can talk about is my personal experience with the cluster duct protocol when we open sourced it. And this can be summarized with a tweet by none other than Francois Cholet. Sorry if I mispronounce it. Excuse my French. So he said, having a solid product is good. What's better is to have a fast and reliable process for continuously improving it. This is why open source has such an unfair advantage. I'm going to repeat the last part again. This is why open source has such an unfair advantage. So Francois Cholet, he's a creator of Keras, for those who are in the deep learning world. And I'm a huge fan of TensorFlow and Keras, and I actually use TensorFlow a lot. So I admire all his work. So yeah, so this is what I experienced. And if you actually notice, he tweeted this 2 weeks ago, and when I saw it, like September 25, when I saw it, I'm like, I have to put this in my presentation. This belongs here. It was a perfect timing. But yeah, so I believe that because when we, let me just go back. So I actually do believe that when we have the code open source and anybody can use it, everybody can use it for their own purpose and be able to help contribute their problems, help contribute code that might actually fix the current protocol or add more features that benefits the whole protocol. And these are some examples of what Francis Cholet about why is open source such an unfair advantage. Because we were continuously improving it by collaborating with our open source community. These are just a few projects that we are doing with our community. One of them is University of Puerto Rico and Mahi West. After Hurricane Maria, we targeted University of Puerto Rico as a pilot program where we deployed the cluster duct protocol on buildings on the university throughout the campus. So that way it was like a user case where we tested out how well our communication network works. And we also, one of our coolest projects we did was something called Space Ducts with the California Polytechnical Institute. where we actually deployed a duck on a weather balloon and let it out into the space. And we had the whole purpose of that project is be able to see how efficient our cluster duck protocol is. We had a duck on the ground and we had a duck on the weather balloon, and the weather balloon went up about like 85,000 feet. Sorry, I don't know how many that is in kilometers. But yeah, and we were able to close a link 50 kilometers away. So granted, it is line of sight, so there's no obstacles between the two devices, so that's why we're able to close that big of distance. But yeah, so the whole plan is to just iterate on it and just push our protocol as much as possible to see the benefit of it. We also collaborate with Northeastern University, and what they did is they work on visualizations and security to help improve our algorithms and our network status. And we also work with Columbia University, where they actually helped us convert from protocol version 2 to cluster duck protocol version 3 using Bloom filter. It's like a hashing algorithm that helps with hopping between ducks. That's too much into detail, but hopefully now that when you think connectivity, you think having a simple, resilient network made by everyone can make a difference in critical times. So critical, you can think of like natural disasters. You know, when a natural disaster hit, just imagine you're in that scenario, and if you cannot communicate with anybody, then it's a devastating feeling. Network, we have the communication network. If we deploy this LoRa technology, people can communicate effectively within that network. And what I mean by everyone is the open source community. So since we open source it, everyone has an opportunity to test it out and experience it for themselves and help improve our protocol. So a little bit about OWL integrations. We were formerly known as Project OWL, and what happened was in 2018, IBM and the David Clark Foundation, they had an initiative that they had a global hackathon that got people around the world, all these developers around the world, to help solve relief with natural disasters. And in November of 2018, 5 of us came together to form Project OWL, and we actually won the competition, the global hackathon. And we noticed that connectivity was such a huge issue. So that's when we took our project and turned it into a company with the mission of connecting the people, places, and things you care about the most. And in addition to the communication technology, we're adding a layer to it. We're adding a sensor network where we integrate sensors to our ducks so they can figure out what's happening around the environment. And we're trying to apply it to oil rigs. So in oil rigs, there are times where there's fugitive methane leaks, where there's methane leaks that's causing environmental issues. But if we deploy this simple technology, simple communication network with sensors, and if they can detect methane leaks, then the operators can get alerted of, oh, there's a methane leak, we need something to fix it. So that way we control the methane in our atmosphere. And yeah, that's it. Thank you. And if you would like to contribute to Cluster Duck Protocol, that's the site. If you want more information with OWL integrations, that is our website. And my name is Taraqur, and thank you for listening.
Fantastic. Thank you so much. Now I'd love to pass to the floor now and ask if anyone does have any questions based on the presentation. I think you've covered absolutely everything. Thank you so much. It was such a pleasure, and enjoy the rest of the show. Thank you.